Ever wondered why we don't fall off the edge of the Earth? This intriguing question has sparked debates for centuries. Some believe our planet is a flat disk, not a sphere. This is known as the flat Earth theory. It's a fascinating concept, one that challenges our understanding of the world around us. But what does science have to say about it? How does it explain the shape of our Earth? Today, we delve into the science behind the shape of our planet. First, let's explore the idea of a flat Earth. The flat Earth theory, in its simplest form, posits that our planet is not a sphere, but a flat plane or disk. This concept may seem outlandish today, but it was once the prevailing belief among many ancient cultures, including the early Egyptians and Mesopotamians. The flat Earth model re-emerged in the modern era with the establishment of the Flat Earth Society in the mid-20th century. This group, led by Samuel Shenton and later Charles K. Johnson, staunchly rejected the idea of a round Earth, instead promoting a model of Earth as a flat disk, with the Arctic Circle in the center and a wall of ice, which we know as Antarctica, forming the outer edge. But why, in the face of overwhelming scientific evidence to the contrary, does this theory continue to find supporters? One reason could be a general mistrust of authority figures and institutions, particularly in an era of widespread conspiracy theories. Additionally, the flat Earth model, with its intuitive, see-it-to-believe-it appeal, might seem more accessible to some than the abstract, math-heavy model of a spherical Earth. Famous proponents of the theory, such as rapper B.O.B. and reality star Tyler Tequila, have used their platforms to spread these ideas, further fueling the debate. However, it's important to note that these celebrities are outliers, and the overwhelming majority of people, including scientists and educators, support the round Earth model. Nevertheless, the flat Earth theory has sparked fascinating discussions and debates about scientific truth, perception, and the role of skepticism in our understanding of the world. It's a reminder that our perception of reality is often shaped more by our beliefs and biases than by empirical evidence. But does this theory hold up against scientific scrutiny? Stay tuned as we delve deeper into the evidence supporting the round Earth model and debunk some of the most common arguments made by flat Earth proponents. Whether you're a skeptic, a believer, or just curious, we promise it's going to be an enlightening journey. Scene script. Science says we live on a spherical planet. Let's explore why. Our planet's round shape has been known for thousands of years, and there are many observable phenomena that support this fact. Let's look at 3 key examples: lunar eclipses, ships disappearing over the horizon, and the visibility of stars from different latitudes. First, consider a lunar eclipse. This celestial event occurs when the Earth moves between the Sun and the Moon, casting a shadow on the Moon's surface. If you've ever witnessed a lunar eclipse, you might have noticed that the Earth's shadow on the Moon is always round. This is consistent with a spherical Earth. If our planet were flat, wouldn't we expect to see a flat shadow instead? Next, let's talk about ships disappearing over the horizon. If you've ever watched a ship sail away from the shore, you may have noticed that it gradually disappears, starting from the bottom of the ship and ending with the top. This phenomenon is due to the curvature of the Earth. As the ship moves further away, it begins to dip below the horizon because of the Earth's round shape. On a flat Earth, we would expect the entire ship to remain visible, just getting smaller as it moves further away. Finally, let's discuss the visibility of stars from different latitudes. As you move from the North Pole to the equator and then to the South Pole, the constellations you see in the night sky change. This is because our perspective of the sky shifts with our position on the Earth. On a spherical Earth, we can understand why different stars are visible from different latitudes. But on a flat Earth, wouldn't we expect to see the same stars no matter where we are? Each of these observations points to a round Earth. The evidence is right in front of us, visible to the naked eye and supported by centuries of scientific research. So, when science says we live on a spherical planet, it's not just a theory, it's a fact grounded in observable reality. Now let's debunk the flat Earth theory using science. The flat Earth theory suggests our planet is not a sphere but a flat disk, a concept that has seen a surprising resurgence in recent years. However, when we apply the principles of science, the flat Earth theory falters on several fronts. Firstly, there's the issue of gravity. In our observable universe, gravity pulls everything towards the center of mass. For a spherical Earth, this means gravity pulls us down towards the center, no matter where we stand. But on a flat Earth, gravity would pull towards the center of the disk, meaning it would always pull slightly sideways. Not only would this make standing upright near impossible, but it also doesn't align with what we experience daily. Next, let's consider time zones. Time zones exist because the Earth is rotating, allowing different parts of the world to experience day and night at different times. If Earth was flat, we would all experience daylight and darkness at the same time, which we know is not the case. Then there's the Coriolis effect, a phenomenon that affects the path of anything moving across the Earth, like wind and ocean currents. This effect is directly linked to the Earth's rotation and its spherical shape. On a flat Earth, we wouldn't see the Coriolis effect, yet it's observed daily in weather patterns around the globe. Finally, evidence from space missions provides some of the most compelling support for a round Earth. Astronauts going back to the Apollo missions have observed and photographed Earth from space, showing it as a sphere. Satellites, too, rely on our planet's round shape to maintain their orbits. The flat Earth theory fails to explain these natural phenomena and observations. In contrast, the round Earth theory accounts for all of them, and more, providing a comprehensive and coherent explanation of our world. So, the scientific evidence overwhelmingly supports a round Earth. But, what if the Earth was flat? Imagine for a moment a world where our planet is not a sphere, but a flat disk. This would drastically alter our understanding of gravity, travel, weather, and even the concept of day and night. If the Earth was flat, the force of gravity would behave differently than it does on a spherical Earth. Gravity pulls everything towards the center of mass, so on a flat Earth, it would pull everything towards the middle. This means if you moved further from the center, you would start to feel like you were climbing a steep hill. Now consider travel. Circumnavigating the globe would be a much different experience. Instead of continuing in one direction to eventually end up where you started, you would reach the edge of the world and have to turn back. And what about flights? They would have to be recalculated, as the shortest distance between 2 points would no longer be a straight line. The weather too would be drastically different. Without the Earth's rotation, we wouldn't have the Coriolis effect, which helps to create our weather patterns. We might end up with one massive supercontinent experiencing extreme temperatures, with a frozen outer edge and a scorching hot center. And let's not forget about our daily cycles. If the Earth was flat, we would all experience sunlight at the same time. The sun would never set, and there would be no time zones. Imagine the entire world operating on the same clock. A flat Earth would also affect our view of the cosmos. We wouldn't see the same constellations in the sky as we moved from the center to the edge. And eclipses? Those would be an entirely different spectacle. So you see, a flat Earth would not simply be a matter of changing our maps. It would alter every aspect of our lives, from the mundane to the spectacular. A flat Earth would be a very different world indeed. So, is the Earth flat or round? We've taken a journey today, exploring the fascinating question of our planet's shape. We've delved into the realms of both fact and fiction, and scrutinized the evidence, seeking to answer this age-old query. We started with the big question, the one that has sparked countless debates. We then ventured into the murky waters of what could be fact or fiction, teasing apart the threads of belief and evidence. From there, we turned our gaze to the evidence for a round Earth. We spoke about the curvature of the Earth visible from high altitudes, the shape of the Earth's shadow during a lunar eclipse, and the way different stars are visible from different parts of the world. Each piece of evidence builds on the next, painting a picture of a world that is not flat, but round. We also took a critical look at the flat Earth theory, dissecting its arguments and finding them lacking when compared to the overwhelming scientific evidence. And finally, we let our imaginations roam, pondering what life on a flat Earth might look like. It was a fun thought experiment, but one that ultimately doesn't align with our scientific understanding. While the idea of a flat Earth is intriguing, science tells us our planet is round. Thanks for joining us on this exploration of our world's shape. Stay curious.